Sequences, sequences, sequences. We've looked at arithmetic sequences, and now we're going to take a look at geometric sequence. And you may recall that an arithmetic sequence is going to be characterized by a common difference, where there is a common difference between the numbers in the sequence. But with a geometric sequence, we have what is called a common ratio. And we can determine the common ratio by taking the second number in the sequence and dividing it by the first. We come up with this ratio. And then we can take that ratio and multiply the second number by that ratio. And if that in fact equals the third, and so on and so forth for each number in the sequence using that common ratio, then we have a geometric sequence. Now we've been asked in this set of problems to determine whether each sequence is arithmetic, geometric, or neither, and then give an explanation. And our explanation is going to be whether we found a common difference or a common ratio. So let's take a look here first at this first sequence of numbers where we got 1, 3, 9, and 27. So I first may say, okay, well, is this an arithmetic sequence? And I take 3 and subtract 1 from it, and that comes to 2. But 2 plus 3 is equal to 5, not 9. So I'm going to rule out that it's an arithmetic sequence pretty quickly. But let's see if it's a geometric sequence. When I take 3 and divide it by 1, and I come to a ratio of 3, or 3 over 1, and let's take this 3 and multiply 3 times 3. Well, I do in fact come to 9, and I take 9 times 3, and that's 27. And so I'm going to say that this is a geometric sequence. And my explanation is that I have a common ratio of 3. Geometric sequence. Now let's look at this second sequence. So I've got negative 20, negative 15, negative 10, negative 5. Well, I'm going to first try to determine, is this an arithmetic or an arithmetic sequence? And let's see, the difference between negative 15 and 20, well, that's 5. And the difference between negative 15 and negative 10, is also 5. And the difference between negative 10 and negative 5 is 5. So in this sequence, I'm saying that this is an arithmetic sequence. We'll abbreviate sequence there, because we've got a common difference of 5. Okay, that's not too bad. All right, so let's look at this third sequence. I've got 2, 8, 14, and 22. Well, let's first check to see if it's arithmetic. Well, the difference between 8 and 2 is 6. But 8 plus 6 equals 14, so there's a common difference of 14. So looking like an arithmetic sequence. But when I add 6 to 14, I don't come to 22, I come to 20. So it's not an arithmetic sequence. Now let's see if it's a geometric sequence. Well, if I take 8 and divide it by 2, that's 4. But 8 times 4 does not equal 14, it equals 32. So it's not arithmetic, it's not geometric, so I'm going to say that this is neither. It's neither arithmetic or geometric, and it's because there is no common difference and there is no common ratio. So again, an arithmetic sequence has a common difference. A geometric sequence is going to have a common ratio. We determine the common ratio by beginning by taking the second number, dividing it by the first. We come up with that ratio, and then if we can multiply that ratio to the second number and get the third and every number in the sequence thereafter, we can determine we've got a common ratio.